Now we're going to use a straight edge and make a line. It's going to be our transversal. And then we're going to make a parallel lines going through that. I can go on either side of my ruler to be sure that they're parallel. Name each one of those angles with a number. You can label them any way you wish. If you label your lines or your angles with numbers like mine, then you can follow the notes all the way through. The transversal, we can label it T for transversal. The other two lines we can label A and B. Usually there's little arrows at the top of every line and bottom. But to indicate that it is parallel, we often have an arrow in the middle. If you see an arrow in the middle of the line, that's indicating that it's parallel to the other line with the same number of arrows. So we've numbered our angles, and now we're going to look at the corresponding. Remember what corresponding is. When you have a vertex, the angle up and to the right corresponds with the other vertex up and to the right. You could look at the angle down and to the left, down and to the left. 6 and 8 would be corresponding. Down and to the right. 5 and 7 would be corresponding. What do we know about our corresponding angles? Well, if you take your tracing paper and trace out angle 5, or any angle you wish, compare that with an angle that it corresponds with. There's really only one angle that's considered corresponding to angle 5. Since that is down and to the right, I go to the other vertex and I have to go down and to the right. So angle 7. And if you look closely, they should line up exactly like number 5 did. So that's showing that angle 5 and angle 7 were congruent. So if the two lines are parallel, then corresponding angles are congruent. Now let's look at alternate interior angles. Remember, the interior angles are the ones in between the two lines. So 2 and 3, 6 and 7, those are interior. They're in between our two lines. So let's trace out one of those angles. So I have angle 2 I've traced out. Now we talked about before that alternate interior angles made a Z shape or a zigzag. In this case, our zigzag would come down to trace out angle 2, and then it comes across the transversal to the other vertex, and it would continue to go down to the transversal, and keeps going down from vertex to vertex and down. So 2 and 6, they make the zigzag shape. 2 and 6 are considered alternate interior. So if this angle was angle 2, we spin this around to see if that's going to be the same as angle 6, and you notice that it is. So angle 2 is congruent to angle 6. You need to know where alternate interior angles are. You need to be able to identify them. Next, we're going to talk about alternate exterior angles. Well, if interior angles were in here, alternate exterior angles are on the outside of your two lines. So these are the exteriors. Alternate means on opposite sides of the transversal. And remember, they need different vertices. So it's not going to be 1 and 8, but it's going to be 1 and 5, or 8 and 4. They're on opposite sides of the transversal, and they have different vertices. So we can trace out angle 1. And we'll compare that with its alternate exterior angle. Which one was that? Angle 5 is alternate exterior. It's on the outside of the shape, not on the inside. And it's alternating, meaning it's on opposite sides of the transversal. So we come over here and try to line it up and see if it can lay completely on that angle. And it should be exactly on there. So I see that angle 1 is congruent to angle 5. So if two lines are parallel, then alternate exterior angles are congruent. Okay, let's look at another type of angle. We're looking for consecutive interior. Which angles up here are considered consecutive interior? Well, the name has interior in it, so you know that it's going to be inside your two lines. It's going to be an interior angle. So you have to be talking about these angles. We need two angles with different vertices. We've already talked about 2 and 6 as alternate interior, 3 and 7 as alternate interior. So if they're consecutive interior, they're interior angles on the same side of the transversal. So that's going to be 7 and 6. Let's take a look at 7 and 6. This one's a little interesting. We'll trace out angle 6. There's angle 6. If we bring it over to compare it with angle 7, you'll see that it's much too small. Angle 6 is acute, while angle 7 is obtuse. So they are not congruent. Consecutive interior angles are not congruent if the two lines are parallel. But what are they? Well, what about 6 and 8? 6 and 8, what type of angles are those? Notice from the vertex, they're both down and to the left. Down and to the left. So we call those corresponding angles. If you trace them out, they make that F shape. So those are considered corresponding angles. Well, we know that corresponding angles, there's the angle 6, there's the angle 8, those are supposed to be congruent. Well, if 6 and 8 are congruent, what do you know about 8 and 7? They make up a straight line. They are supplementary. 8 and 7 happen to be a linear pair. They add up to 180. Well, 6 and 8 definitely are not a linear pair. They don't have the same vertex. 6 and 7 don't have the same vertex. But they do add up to 180, so they are supplementary. 6 and 7, 3 and 2 are going to be supplementary also. So down here, angle 2 is not well, let's say angle 6, that's the one we were talking about. Angle 6 is not congruent to angle 7. Okay, but what we do know, angle 6 comma angle 7 are not a linear pair because they aren't adjacent to each other, but angle 6 comma angle 7 are supplementary. They do add up to 180. They add up to 180 for the same reason. 6 and 7 add up to 180 for the same reason 8 and 7 add up to 180 degrees. 6 is the same measurement as 8. So we could substitute that in essentially. We know that 8 and 7 are a linear pair. They add up to 180. And if 8 is equal to 6, then 6 and 7 add up to 180. So on our last page, these are very important theorems because they're going to be the ones we use in our proofs. And we're going to use these pretty much throughout the whole year. First of all, we're going to start out with one called the postulate. Remember, a postulate is a statement we assume to be true. A postulate is a statement we assume to be true. So if two parallel lines are cut by a transversal, then the pair of corresponding angles, both up and to the right, from the vertex, up and to the right, what do we expect to be true about corresponding angles? What did we say on the other page? We said that they were congruent. So if two lines are cut by a transversal, then a pair of corresponding angles are congruent. And the wording for proofs is if parallel lines, then corresponding angles congruent. That's a postulate. We wouldn't prove that that one exists. We're going to allow that one to be true. And then from that, we could go ahead and prove all the rest of these. Here's a theorem, alternate interior angle theorem. If two parallel lines are cut by a transversal, then the pair of alternate interior angles. What do you remember about the alternate interior angles? If you have to look back on the other sheet, go ahead. They are congruent also. So your wording for proofs is if parallel lines, remember they are coming first in this lesson. They are the part that have to be there. If parallel lines, then alternate interior angles are congruent. You can spell the word or you can use the symbol. You have to say alternate interior. Don't just say angles, because not every angle is congruent, so you can't just say angles. You got to name the type that you're working with. If two parallel lines are cut by a transversal, then pairs of alternate exterior. What do you remember about alternate exterior? They are congruent. We talked about that on the previous page. So if parallel lines, if you have parallel lines, then alternate exterior angles are congruent. Then our last one, if two parallel lines are cut by a transversal, then the pair of consecutive interior. Look what the consecutive interior angles are. They're on the same side of the transversal, and they're both interior. They always have different vertices. Are those congruent? No, those are supplementary. Those are the only ones that are different. All the other types are the same measurement. These add up to 180. If parallel lines then consecutive interior angles are supplementary. Have fun.